Hi everyone, thank you for your time. In this particular video, you are going to be taking a look at one of the interesting projects that we are going to be working on, which is nothing but predicting the diabetes in a patient. We use various machine learning and data science models in order to predict whether a person is going to suffer from diabetes. Now, in order to use machine learning or data science, we would have to first load the data, which is the first step, and then we have to perform some pre-processing that is important. And once the pre-processing is done, we need to use various machine learning and deep learning models to train the model, and then finally use that data and divide it into two parts. We use the test data to see how well our model is actually doing. Therefore, we have to do all of these steps, which will be going across in this particular video. Now, initially, the thing is, we have a library called sklearn, which has pre-built data sets that we can be using. We will be using the diabetes dataset in our use case, and let us get started. So I just say from sklearn dot datasets import load diabetes, and as you can see, this is a Google Colab notebook where the data is getting imported. The next step that we do is to just take a variable called data and then just assign it with diabetes, and then we have the data assigned. And if I just print out the data, we see that it is in the form of an array where we have the data, we have the target, and so on. This is nothing but the sugar levels that, or the diabetes levels that we are going to be predicting, which is the target here. But in order to get a clear understanding, let me also take input, output, and so on, and get the description. And if I say no, I think it should be data. Okay, let me first get the description of the data, and then here we have the description. But in order to make it clear, let me just print out the description to see the type of features that we are taking. We take age, we take sex, we take BMI, we take the blood pressure, and we do take a lot of other factors. It will be great if we have a domain knowledge in this field before we can apply data science and machine learning. But it's a good practice to start with this toy data set to get an understanding about how data science is actually being used. Once we have seen that we have 442 instances, which means we have data of 442 examples or patients, if we can assume that each instance represents a single patient, and we have 442 such patients, and we do have these as the features, and now we got an understanding. Now let me just export only the data from this. Let me see if this works. Yes. So let us make this as input to the machine learning models, and the output can be equal to target, which we'll do in this case. Therefore, now I want to look at the shape of the input data that I'm giving. So if I just say x dot shape, we get the shape. Note that we have 442 instances and we do have 10 features. Similarly, if I take a look at the shape of our output, which is nothing but the target labels, we find we have 442 instances. The next thing that we need to do is to divide this data into two parts, training part and the test part, which we will do using a library called train test split, which I'm going to import. So if I just say from sklearn.model selection import train test split. Now what this train test split does is it divides the data into two parts and makes it easy for our machine learning model training. The first part, which usually consists of 70% of the data, we give it for training our models, and the remaining 30% we use it to test the models. Now let us first divide the data. We just say x train, x test, y train, y test, train. We are using this module. We give input, we give output. We just say test size equals to 0.3, which means we are considering only 30% as the test data, and then we just say random state equals to 101, Why we use random state is basically if we are trying to repeat this experiment and we want to divide the data in the same way that we did last time, then we just say random state and we give the same number that we gave previously, so that we get the optimum division. Now I just keep random state equals to 101 so that these results are again reproducible when I run this code again. Now let me just look at the training data. We just say we just look at the shape of the training data. We have 309 instances, and similarly we take a look at the test data. We do have 133 instances, which is really good. Now we'll have to use various machine learning and deep learning models. Let us now, for the sake of simplicity, use linear regression, which is a standard form, and it is much more easier to interpret linear regression, and let us do that. So I just say from sklearn I guess it should be linear models, import linear regression. I believe this should work, or should it be linear model? I believe it should be, yes. Therefore, we just say from sklearn.linear model import linear regression, and we just say model equals to linear regression, which is the first task, and then we train the model. We just say xtrain, ytrain. When we are training the model, we just need to fit the training data. Xtrain is our training data and ytrain is the output that we want, and we want our model to understand the input and then make predictions on the output, which is the y-test. Now we just take one variable called y predictions, and then we ask the same trained model to predict on the test data. Now when we look at it, we are getting the predictions for the x test, which is nothing but the test data. We have the output for the test data, which we already have it here. Now we are going to test how well our models did for the output data. If we just say y predictions, we get predictions given by the model, and if we take a look at y test, we get the actual values here. Now we are going to see how much of a difference there is going to be between the y predictions and the y test. We do it using various metrics like mean squared error or root mean squared error. We'll import the mean squared error to get an idea. So from sklearn, we just say mean squared error, and we are able to import the mean squared error. Now let us take a difference between the test value and the predictions. We just get the predictions, and so this is the mean squared error that we got. The next thing is we can also import one more metric called mean absolute error, which we will do right now. And we just say from sklearn.metrics import mean absolute error, and then we are importing that one, and then we just take a difference between y test and y predictions, and overall we got an error of 46, which means that we are doing a good job overall when it comes to machine learning predictions. So this is the overall workflow of how we do machine learning. The first thing is we take the data, we load the data, and then we see the data in this way. The next step would be to get a description of the data, understand some important features from the data. Finally, we take the shape of the data. We use the train test split to divide the data into two parts. We see how many samples are there in the training data and on the test data. We use various models like linear regression to find out how well our model is doing. And then these are the predictions given by the model, and these are the actual outputs. And then we try to see the mean squared error between the predictions and the actual values, and then we get the final output. And thank you so much for tuning in. Have a great day.